Hello, so today we're presenting our partial project. I'm Angela Vera.
And I'm Camila Perez.
So we're team 16, and so that means that we're presenting the problem 11 in linear functions, 12 in quadratic functions, 13 in radical functions, and 16 in rational functions. So first, the problem of linear functions. So first, you have to take the slope, and the slope is always in the functions is always the one that comes with the x, the number that comes with the x. So here you don't really have to use the formula. So here our slope will be -7. And then after you take the slope, you have to find the x-intercept. And for doing this, you need to equal the y in the function to 0. In this case, fx will be equal to 0. And you can see it here how you have to clear for x. And the answer is 1/4, 0. After you figure the x-intercept, you have to find the y-intercept. And basically what you have to do here is to equal the x's in the formula to 0. So here we can see how you equal the x's in the formula to 0. And you cancel this one because it will be 0, and the answer is 0.7/4. After you have these 2 points, you have to graph it. And in here you can see that the y-intercept is here and the x-intercept is here. And once you graph it, you have to take the domain and range, which in here will be -∞, +∞, and the range will be -∞, +∞. Now for the problem of quadratic functions, this is the function. So first you have to identify a, b, and c. So in this case, 5 is a, -2 is b, and -3 is c. After you find this, you have to find the axis of symmetry, and you have to use the formula h equals -b divided by 2a. And in here you take the axis of symmetry, and to take the vertex, you have to substitute the x's with 1/5, so you can get the y in the vertex. So this will be the answer. After you figure the axis of symmetry and the vertex, you have to find the x-intercept, and you use this formula. And you do the process. And in here, when you get to the root, you have to split them into negatives and to positives. So you will have 2 answers, and these are the 2 points of the x-intercept. After you have the x-intercepts, you have to find the y-intercepts. And you do the same as linear functions. You just substitute the x with zeros, and you get the answer. And then you have to graph it. And here you can see the axis of symmetry, the 2 x-intercepts, the y-intercept, and the vertex. Once you have the graph, you have to take the domain and range, and the domain will be -∞ and infinite positive, and the range will be -16 16/5 and negative. I mean infinite, positive infinite.
Then we have the radical function. And when you have a radical function, the first thing you need to do is to analyze the problem to see how our graph it's going to look like. For example, in this one, we can see that the number outside the square root is positive and the x is positive. So according to the little graph we have over here, it's going to be up and right. So the next step is to take the expression inside the square root and equalize it to 0 to get the x. We have x plus 2 equals to 0, so x is equals to -2. To get the y, you need to look outside the square and see if there is any number adding or subtracting to the square root. For example, we have this -2, that will be the y. And then to get the x-intercept, we need to get the coordinates for x and y. And we have x is equal to -2 and y is equal to -2. And once we have our starting point, we need to make the table to connect the possible next points and graph them. So we have x could be 0 or 1, and we have to replace it in the whole, for y, we have to replace it in the whole expressions. So that way we can know where we're going to be plotting the points. And to find the y-intercept, we need to look at the graph and be able to tell if any of the points will touch the y-axis. So if we can see there are no points that are going to touch the y-axis, so the y-intercept does not exist. To get the domain, you need to look left to right. And then the first number you see is the first number until the infinite. For example, we need left to right, and the first number we can see is -2 in the graph. So the domain will be -2, positive infinite. And to get the range is the same, just in this case, we need to look from bottom to top, and we can see the -2 to positive infinite. Then in a rational function, the first thing to do is find the vertical asymptote, and we can do that by equalizing the denominator to a 0. In the rational functions, we always have a vertical and a horizontal asymptotes. The asymptotes are imaginary lines that the graph will never pass over it, and we use dotted lines to represent it. For example, we have, for the denominator, we have 2x minus 8 equals to 0, and then we solve for x is equal to 4. Then we need to find the horizontal asymptote, and we need to look at the denominator. If there is not x, then the y is equal to 0. If there is an x on the top, then we need to cancel them. As we can see here, we have an x on the top and x on the bottom, so we need to cancel them, and it's y is equal to 1/2. To get the y-intercept, we need to equalize the whole equation to 0 and solve it. In this case, we can see that x is equal to 0. In order to get the y-intercept, we need to replace all the x's we have in equations to 0. For example, f(x) now is f(0) is 0 over 2 plus 0 minus 8. And we have all the equation to 0 over minus 8, that's equal to j is equal to 0. And once we have all this information, we are going to be able to graph the whole thing. And finally, to get the domain and the range, the only thing we need to do is to find the domain and use the vertical asymptom to the infinite. And you have to put first the negative infinite, comma, the vertical asymptom, and you close the parentheses. You need to use the union symbol, and then you're going to put backwards the vertical asymptom, comma, positive asymptom, and you close the parentheses. For the range is the same thing. You only need to use, instead of the vertical asymptom, you need to use the horizontal asymptom. And that's going to be all for our explanation.